Hi and welcome to the video training of Elixir. In today's video training we will be learning about error mechanisms in Elixir, which are try, catch and rescue. So let's get started. Elixir has three error mechanisms: errors, throws and exits. In this chapter we will explore each of them and include remarks about when each should be used. First, let's look at errors. Errors or exceptions are used when exceptional things happen in the code. A sample error can be retrieved by trying to add a number into an atom. So let's get into the Elixir runtime environment and interactive mode, and let's try the code foo +1. And we get an arithmetic error. It says bad argument in arithmetic expression. Runtime error can be raised anytime by using raise keyword. So if I say erase, oops, we get a runtime error. So that's how you can throw an runtime error at any time. Other errors can be raised with raise passing the error name and a list of keyword arguments. For example, if we want to raise an argument error and display a message, we can simply say raise argument error and pass a string message saying invalid argument foo, so we get argument error. You can also define your own errors by creating a module and using the def exception construct inside it. This way you will create an error with the same name as the module it's defined in. The most common case is to define a custom exception with a message field. So let's define a module myError. Def module myError do and def exception message default message, and that's the end. And it says undefined function def module. Okay, sorry, I did it wrong. It should be a small m, that's why gave us an error. Now we should be fine. Def exception message default message, and yeah, we are good now. So if you want to raise a custom defined exception that we just defined above, which is called myError, you can use raise myError, and this will throw your default message error. You can also pass a custom message to myError, so you can say message and you can say custom message, and it will show you your custom message right after your myError exception. Errors can be rescued using the try rescue construct. So let's define a try rescue block and experiment our raise exception code rescue, and within rescue I'm going to say e in runtime error e end. Alright, so the example above rescues the runtime error and returns the error itself, which is then printed in the IEX session. If you don't have any use of the error, you don't have to provide it. So we can also use runtime error as well, and we can also define our string as well. Let's look at throws. In Elixir, a value can be thrown and later be caught. Throw and catch are reserved for situations where it is not possible to retrieve a value unless by using throw and catch. Those situations are quite uncommon in practice, except when interfacing with libraries that do not provide a proper API. For example, let's imagine the enum module did not provide any API for finding a value and that we needed to find the first multiple of 13 in a list of numbers. So let's code a try block, and within try block I'm going to use enumeration object each and giving it a range from -50 to step 50 and a function. Within that function we are going to add a check if remainder of x is 13, x divided by 13 is 0, do throw x, and got nothing, catch. Within the catch block I'm going to assign got hash x to x value and end. Since enum does provide a proper API, in practice enum.find is the way to go. So if I use enum.find and give it -50, 50 range, and we are going to use remainder and 13 equals 0, we get -39. So this is how you can use try catch blocks, and you can use enumeration as well. Let's look at the exits. All Elixir code runs inside processes that communicate with each other. When a process dies of natural causes, for example unhandled exceptions, it sends an exit signal. A process can also die by explicitly sending an exit signal. So if we use spawn link function exit one end, you see it sent an exit signal, shell process exited with reason 1, and we have re-entered the interactive mode again. The Elixir shell automatically handles those messages and prints them into a terminal. Exit can also be caught using try catch block. Let's look at the after keyword. Sometimes it's necessary to ensure that a resource is cleaned up after some action that could potentially raise an error. The try after construct allows you to do that. For example, we can open a file and use an after clause to close it even if something goes wrong. Okay, let's define a list. Okay, file equals file dot open a file sample, encoding a UTF-8, and the mode is write. Okay, now let's try do io.write file comma ola raise oops something went wrong after file dot close. Here we are closing the file and ending the try catch block, and it says runtime oops something went wrong. The after clause will be executed regardless of whether or not the try block succeeds. Note, however, that if a linked process exits, this process will exit the after clause and will not get run. Thus, after provides only a soft guarantee. Luckily, files in Elixir are also linked to the current processes, and therefore they will always get closed if the current process crashes, independent of the after clause. You will find the same to be true for other resources like ETS tables, sockets, ports, and more. Sometimes you want to wrap the entire body of a function in a try construct, often to guarantee some code will be executed afterwards. In such cases, Elixir also allows you to omit the try line. So let's define a module run after do def without even trying do raise after io.puts cleaning up and that's the end of the function. And now if I want to call our module run after dot without even trying, that's the method we have defined in the run after module right there, and press enter. It says cleaning up and says run after without even trying. So the after block executed anyways. Elixir will automatically wrap the function body in a try whenever one of after, rescue, or catch is specified. Let's look at the else keyword. If an else block is present, it will match on the results of the try block whenever the try block finishes without a throw or an error. So the else block always execute regardless of the rescue or the try block. Exceptions in the else block are not caught. If no pattern inside the else block matches, an exception will be raised. This exception is caught by the current try, catch, rescue after blocks. Let's look at the variable scope. It is important to bear in mind that the variables defined inside try, catch, rescue, and after blocks do not leak to the other context. This is because the try block may fail, and as such the variables may never be bound in the first place. In other words, this code is invalid. So let's try this code here. Try do block raise fail. What happened equals did not raise, and the rescue block underscore equals what happened equals rescued, and now I'm going to call what happened directly. This is the variable that we have defined within the try catch block, and it says undefined function because that function or that variable is inaccessible from outside the try catch block. Instead, you can store the value of the try expression. So if we keep the value of rescued within the sorry, I misplaced the we are here. So okay, so if you save the value of rescued in the what happened variable, then the value of what happened can be fetched using what happened. Here you can see the difference is what happened equals means whatever is returned by this try catch block is saved into what happened variable, and afterwards we are fetching the value of what happened, and it is giving us rescued. This finishes our introduction to try, catch, and rescue. If you liked this video, don't forget to subscribe to my channel. If you need any help, please feel free to contact me at umehmood@gmail.com. You can visit me at my LinkedIn profile or my Twitter handle. See you next time with a new topic in Elixir.